All right, so as you can see today, my table is full. What we are going to be doing today is we have parts of large format machines here. We are going to be introducing the parts to you. You know their function and basically what they do. Yeah. So let's dive in. So this is the headboard. The large format machine has two boards basically, or let me say three boards. We have the power boards and we have the headboard, and this is the main board. This main board receives power and also transmits power to the headboard. It also receives information and transmits the same information to the headboard. So the two of them work hand in hand, they work together. So this is the headboard and this is the main board. The print head of the machine is connected to your headboard. There are different types of headboard depending on the kind of machine you use, but this is a Sengyang board. That's the name of the board. We have lots of board depending on your machine type or the machine manufacturer. We have the printed cable. It also comes in different types depending on the type of printhead you use and also the type of board. Now, this is for XP600 printhead. We have DX5 printhead, we have DX7 printhead, we have i3200, we have XC90, we have XP6000 printhead. There are lots of printhead. So depending on the type of machine you use or the type of board that is on your machine, type of printhead you decide to go for to determine the type of cable that will be used. So this is the screen, the machine screen, or we call it display, where you have the buttons of your machine and also the display you have. The work of this one is simple. You see all what you are doing on the display. So next is the capping station. There are basically two types of capping station. We call this popularly called the mechanical. Then this is the automatic capping station. See, the automatic is quite bigger. It has a motor, but this mechanical doesn't have any motor. The only thing it has is this lifter. We call it solenoid. So it lifts for the wiper to wipe the printed. So this blue, anywhere you see this blue thing on your capping station, this blue rubber here is the wiper. It wipes the surface of the printhead after it must have pulled ink. That will lead us to talk about cap. Basically, we also have two types of cap. We have the slide cap, then we have the elevation cap. All these caps here, most of the parts we have here are for XP600 because that's the commonly used machine now. But these parts apply to every kind of machine, every kind of printer you use. You find similar parts as we are describing them here on other kinds of machines. So this is the slide type of cap, and this is the elevation type of cap. So this is for the automatic capping station, while this is for the mechanical capping station. The next we are going to talk about are dampers. These are all dampers. There are different types of dampers too in the market. So it depends on what you want to use it for. But you see these long dampers, they are usually used for our friend, our white ink, DTF. It's suitable for white ink, these long dampers. Then these short ones can also be used for DTF too, but for colored, not for the white. You can't use this one for the white ink. This is also for DTF, but this can be used for both large for eco solvent and DTF, and it can also be used for white too. But we don't have the there's also UV dampers. UV dampers, any material for UV, whether the ink pipe and the dampers, basically they always come coated in black color. They come coated in black color. So but these are all for either sublimation, DTF, or eco solvents. Can use any of these white or transparent dampers. Probably in one of our videos we are going to discuss why UV pipes, dampers, and even the containers, the ink containers, all come coated in black. We are going to discuss that in a separate video, so just stay tuned and follow us and we'll explain that to you. So this is the dampers. Now for the dampers, this is an essential part of your machine, be it eco solvent, be it sublimation, be it DTF. On some machines you will see that they write that you change this every 3 months, but in Nigeria, as Sodiq that we are, as Ogbon that we are, we only change it when it starts giving us sign, or when we see that there is no other option for us than to change it. But these are the dampers, and what they do is they serve as an intermediary between your ink pipe and the printhead. So they control the flow of ink from the ink pipe down to the printhead. So this is just like the filter, your fuel filter in your car. It controls the amount of ink that will come into the printhead per time. So this supplies ink to the printhead. I know most of the time people will be wondering how manage you are seeing a flow of ink from your ink tank, but it's being regulated at the spore, or once it's printing. So this is what regulates your pour of ink from the printhead. The next thing we're going to be talking about is our pipe. This an ink pipe. I wouldn't lose it completely, but so that you will see what is there. So this is just a pipe. Yes. So this supplies ink from your ink tank down to the damper. So this connects from the ink tank to the dampers. On some machines, in between, at some points, you see filters. That's mostly for DTF machines. But some companies, some manufacturers also impute these filters for eco solvent machines or sublimation machines, but you find them in many DTF machines out there now. So in between this and your damper, somewhere you see a filter. And what we don't have the filter here, but what the filter does is that it also filters the ink before it gets to the damper. So that will give your damper a longer life. So it's reducing the work your damper does. So this is the ink pipe. Basically, that's what it does. It also comes in different diameters. That's the hole. It's come in different diameters. We'll also talk about the differences in the hole and how they affect your flow of ink, probably in our next video as well. Here we have a media guide. We call it media guide. Yes, as you can see, this is what holds your media or material, be it flex, be it SAV, whatever it is you are printing on, be it mesh, be it flag material, be it paper. This is what holds it down such that it won't allow your machine to jam. As small as it is very important. These are part of the things that reduce or minimizes your machine jamming if you use them effectively. If you don't also use it well, it can also cause the machine to jam. And if you don't use it at all, it can also cause the machine to jam. So you have to use it very well. It also comes in different types, different sizes, and colors, depending on the machine and the manufacturer. So the next thing we're going to talk about is the rail guide. If you remember in our previous video when we talked about you not being Yakubu, I mentioned something called rail guide. This is rail guide. Some people call it slider, some people call it Boris, but the professional name for it is rail guide. And what does this do? This is what aids the movement of your carriage. It moves along a rail. So there are little balls inside called ball bearings. So these balls aid the movement of your carriage smoothly on your rail guide. That sound you are hearing on your machine that is sounding like grinding machine, this is what is at fault. This is what is getting weak. The ball bearings within it are becoming slack. That's why you are hearing that sound. So if you want to get your machine back on track with a smooth sound, to stop sounding like a grinding engine, you need to change your rail guides. And they come in different sizes and different types. They're basically this a smaller size and this is a bigger size depending on your machine. So most 10-feet machine use the bigger size, and the 6-feet machine use the smaller size, and DTF machines use the smaller size. But there are still some 10-feet machines that use the smaller size as well. But basically, these are the two sizes. This is QE15 and this is QE20. That's for this type of rail guide. There are other types of rail guide. We have the TH. Yes, TH15 and TH20 as well. So now we're going to talk about motor. These two are motors, but they serve different purposes. I know you must have been wondering the X and Y you learnt in school. You have not been applying them. You can apply them on this. This is your X motor, while this is your Y motor. X in the sense that this motor controls the movement of your carriage. That's your X axis. While this other one controls the movement of your media or your material, which is the Y axis. You see that the physics that you did in school, that's last, it's not in vain. So we call them this is the X motor and this is the Y motor, and basically that is what they do. For the X motor, which is this, there are basically three types. We have the servo motor. This is a servo motor. We have the DC motor, then we have the BLDC motor. For now, we only have the servo motor here, and the difference within them is just that the way they work. Now this is all incorporative, so this gets power from your power board. Then it has a code here. The code here depends on the setting of this code, depending on the type of board that is on your machine. Then it communicates directly to the main board. Unlike the DC motor connects directly to your main board. It receives instruction from your main board, it receives power from your main board, and that's how it works. Then for the step motor, there is also two types. There is also servo step motor. This is also called step motor. You know, I mentioned this the Y motor, but it's also called step motor. So there are two types. There is servo step motor and there's also DC step motor. So they also work the same way. So the servo step motor receives power from a driver. So there is a step motor driver that drives this. Then this is connected to the step motor driver. Then the step motor driver connects to the board. While the DC step motor connects directly to the board, just like the DC motor we have. So basically that's what these two things. So this is your X motor and this is your Y motor. So as you can see, our table is getting empty, unlike when we started. So this is your Ethernet cable. This is a brand new Follow-Com Ethernet cable. This is what you always find in your machine. The Ethernet cable you can always get anywhere. So this is what sends information from your system to the main board. So this connects from your system to the main board. This also, there are some machines that communicate with USB cable, the conventional USB cables, you know. That's the conventional printer USB cables, you know. But this Sengyang board, this one we showed you earlier, uses network cable to communicate. It uses Ethernet cable to communicate. And one advantage of printing with Ethernet cable is that even when your system goes off, that's not when the system shuts down completely. For example, your system sleeps. By the time you come back, it comes back on. It can continue printing your work from where it stopped. Unlike USB cables, even when you unplug this while your machine is printing, by the time you plug it back, it will continue printing your work. That's the advantage of this Ethernet cables. So the last things I'm going to be talking about in this video are sensors. This is an encoder sensor and this is a limit sensor. Now for the encoder sensor, they come in different types and different forms depending on the kind of board that is on your machine. Now we've been talking about type of board. So basically the encoder sensor also, how it is depends on the type of board or how it is being placed on your machine. This is also an encoder sensor. You see that they are quite different in shape and size. But if you look closely at this black sensor, this black thing you see here is the sensor itself. So how it now look or how it is being fixed on your machine depends on the manufacturer of your machine. And basically this serves as the eye of your machine. It moves together with the rail. It moves on another part we call the encoder strip. We don't have that here. Probably we'll also introduce that in another video. It moves along the encoder strip. The encoder strip moves in between this sensor Okay, the encoder sensor is placed on top of the encoder strip, with the encoder strip in between the sensor, and it moves. So without this, your machine will not even work. It will not even power on in the first place. For some machines, it might start, the machine will get ready, but it won't move. And for some, it won't even come on at all. It will be showing you error from the onset. The next thing here is the limit sensor. As the name implies, limit sensor. So this tells you, for the machine that uses this, it tells the machine you can't exceed this point. You can't exceed this point. So basically, how it works is that there is a metal that this is connected to your board. There's a metal that just comes in between this space, and the machine will automatically stop once this sensor detects that particular metal. So it is usually on machines that use servo motor. When you are using a DC motor, you don't need this limit sensor, but when your machine uses servo motor, limit sensor is a must, and you must always watch out, because there are times the metal will not come in between this sensor, or might not reach where the sensor is, and you start having errors on your machine. You also find this kind of sensors on your automatic capping station, that's the elevation capping station as we showed earlier. So this is also there, because that has a motor that rolls up and down. So it shows the capping station a limit where it must not exceed, whether going up or coming down. So this is what the limit sensor does. So that's all for today. Thank you for staying tuned. And as always, please like, share, and subscribe, because we are here to give you more value. I remain Adeyemi Babajide Emmanuel. See you on the next one.